What if I told you there is a single line of C++ that can replace dozens of messy constructors, and also hide a dangerous trap that can break your entire class hierarchy? Let's reveal the trick and the risk right now. Hey, welcome back. Coffee in hand? Great. Let's dive into clean code C++ and write code you love. Are you still manually copying constructors in your derived classes? You're wasting time and risking dangerous bugs. Today I'll show you a modern C++ trick that eliminates this tedious practice, but beware, there's a hidden pitfall you must avoid. Alright, let's look at a scenario you'll probably face. Imagine we're creating a system to manage user accounts. You'll have a basic user class and then a more specialized registered user class. The registered user behaves a bit differently, but doesn't need to store any extra information compared to a standard user. Here's how we might write this using the traditional repetitive approach. First, let's set up our user class. It'll store a username and an integer user ID. We'll provide two ways to create a user. One that takes both a name and an ID, and other that just takes a name and automatically assigns a temporary ID of -1. Now let's look at the derived registered user class. Since a registered user should be constructible in the same ways as a user, we have to write forwarding constructors for it. Take a look at that registered user class. You see how repetitive this is. The first constructor just takes its arguments and hand them off to the user constructor. The second one does the exact same thing. We're essentially writing the same logic twice, which violates the derived principle. Don't repeat yourself. This is more than just an annoyance, it's a maintenance problem. If a developer adds a new constructor to the user class, they have to remember to also add a corresponding one to registered user and any other similar derived classes. If they forget, you get compiler errors or worse, inconsistent behavior. So how do we fix this? How can we just tell C++ to automatically reuse the constructors from the base class? With a feature introduced in C++ 11, it's incredibly simple. Let's rewrite our registered user class using this modern technique. Look at that, the entire body of the registered user class is now a single line. This one statement tells the compiler I want to inherit and make all of the public constructors from my base class, user, available in this derived class. That's all there is to it. Our registered user can now be created in exactly the same ways as our user without any redundant code. If someone adds a new constructor to user, registered user gets it automatically. This is clean, maintainable, and the way to go where your derived class doesn't add any new data. Now I need you to listen very carefully. This technique is a double-edged sword. Using it in the wrong situation can lead to some of the most insidious bugs you'll ever encounter. Bugs that don't crash your program immediately, but silently corrupts its state. Let's expand our example. Imagine we now need an AdminUser class. An AdminUser has a username and ID, just a regular user, but it also has a new piece of data, an access level. Here is the dangerous code. It compiles without any warnings, but it's a ticking time bomb. We've created an AdminUser that derives from user and adds a new private member, access level. And just like before, we use the same elegant feature to inherit the constructors. What's the problem? Think about what happens when we create an AdminUser object. The constructors we're using are the ones from user. Do those constructors know anything about a member named access level? Of course not. They only know how to initialize username and user ID. This means that when you create an AdminUser, its access level member will be uninitialized. Because it's a primitive int, it'll hold a random garbage value. If you try to read from this member later, you'll invoke undefined behavior. Your program might crash, it might produce the wrong output, or it might seem to work perfectly until one day it doesn't. This is a nightmare to debug. So if inheriting constructors is dangerous, when you add new members, what should you do instead? You have two excellent options. The first option is simple and works perfectly if you're happy with the new member having a safe default value. You can provide an in-class member initializer. Let's fix our AdminUser class this way. The one change is on the line where access level is declared. By adding that default initializer, we're telling the compiler that if no other constructor explicitly initializes access level, it should be given a default value of 1. This guarantees that our new member will never contain a garbage value. Now our use of inheriting constructors is safe again. But what if the default value isn't enough? What if an admin user must be created with a specific access level? In that case, you need to write your own constructor. This is the most robust and explicit solution. Here's what that looks like. In this definitive version, we have defined a specific constructor for admin user. Look closely at the member initializer list. First, it calls the user base class constructor to initialize the part of the object inherited from user. Then it initializes its own access level member. There is no ambiguity. To create an admin user, you must provide all the required information, and every single member is guaranteed to be properly initialized. This code is safe, clear, and easy for other developers to understand. What's the bottom line here? The guideline is simple but absolutely critical. Use inheriting constructors only when your derived class adds no new data members. It's a fantastic tool for reducing boilerplate when you're just specializing behavior. But the moment you add new state, a new data member in your derived class, a big red flag should go up. At that point, you must take control of initialization yourself, either by providing a safe in-class default initializer for the new members or by writing explicit constructors that initialize both the base and derived parts of the object. Following this rule will help you write code that is clean, modern, and most importantly, safe. Nice job sticking with me through this quick session. If you're excited for more, my masterclass is right at alcoacademy.com. Plus, I've got a bunch more cool stuff on this channel. Don't miss it. Be sure to like this video and share your feedback in the comments.